All right, let's jump right in. Today, we're talking about a massive, literal game changer in artificial intelligence research. We are finally moving past the era where AI merely writes a few helpful code snippets for us. We are entering an entirely new frontier where AI is actually hypothesizing, designing, and inventing brand new machine learning algorithms completely on its own. So that begs the ultimate question, right? Can AI actually invent new AI? It sounds a bit like sci-fi, I know, but we're going to explore a very real system today that builds, debugs, and tests novel algorithms completely from scratch with zero humans in the loop. The stakes here are absolutely huge. I mean, automating this could put the evolution of artificial intelligence on hyperdrive. Here's how we're going to break it down today. First, automating AI discovery. Then, we'll go inside the Omega framework, look at its self-healing loop, see how it beats human baselines, and finish up with a really cool experiment on optimizing prompts versus code. Okay, part 1. Automating AI algorithm discovery and moving from manual research to automated factories. Now, before we get to this shiny new solution, we kind of need to talk about the bottleneck in traditional machine learning research. For years, translating a theoretical, mathematical hypothesis into actual executable code has been painfully slow. It's a stubborn, manual, highly frictional process. Sure, we have automation tools like AutoML right now, but let's be honest, those mostly just tune the dials on existing models. Discovering completely new algorithmic logic, that has been strictly a human job. Until now. That brings us to Section 2. Let's look inside the Omega framework, essentially a factory for algorithmic discovery. So here is the solution the researchers proposed, the Omega framework. Omega stands for Optimizing Machine Learning by Evaluating Generated Algorithms. The genius here is that instead of treating a large language model's output as just a static chunk of text, Omega treats it as a dynamic executable system. Imagine a closed-loop factory assembly line. A raw idea comes in at the start, travels through an AI generation phase, hits a self-healing quality control loop in the middle, and then moves into an incredibly rigorous evaluation stage at the very end. To make that a bit more concrete, it's really a 4-step pipeline. Step 1 is idea generation, which can come from a human prompt or entirely autonomously from an LLM. Step 2 is code generation, and this is crucial. Omega specializes in generating standard API-compliant scikit-learn estimators. It's making literal plug-and-play code for standard industry pipelines. Then comes Step 3, self-healing, followed by Step 4, evaluation. Let's dive into that third step for Section 3, the self-healing code loop, because unexamined code is just not worth using. Look, if you've ever used an LLM to write code, you know the painful reality. It crashes, it hallucinates syntax errors, it just flat out fails to compile on the first try a lot of the time. An unexamined piece of AI code is basically useless in a real production environment. So Omega fixes this with a self-healing mechanism. If the code throws an error, the system automatically captures that stack trace and feeds it directly back to the LLM. The AI effectively becomes its own debugger, iterating over and over until the code is completely error-free. Nothing broken makes it out of the factory. Moving to Section 4, beating human baselines and entering the infinity bench arena. But here is the real test, right? How do we know these self-healed, AI-generated models actually work in the wild? Compiling without errors is one thing, but accurately classifying complex data is a whole different beast. So the researchers created what they call Infinity Bench. It's a 20 dataset gauntlet designed to push these models to their limits on pure robustness and accuracy. And because some datasets are just naturally easier than others, they use a min-max normalized scoring system. Basically, they grade on a curve, ranking the algorithms relative to each other, so easy datasets don't artificially inflate a model's true capability. And the results? They are kind of mind-blowing. When you stack standard, heavily optimized human-engineered baselines, things like logistic regression or random forest, up against the algorithms dreamed up by Omega, Omega decisively and consistently wins out. The AI-generated algorithms are hitting the top rankings across the board in this infinity bench gauntlet. Let's actually look under the hood at 2 of these winning algorithms. The absolute best performer overall was the MetaSynthesisClassifier, which, interestingly, started from a human prompt. But the 4th best model, called the directional forest, was generated entirely by the AI system itself, using just a broad list of research principles. No human hand-holding required.
The metasynthesis classifier uses a meta-learning approach. Think of it like a really smart manager delegating tasks to a team. It looks at the probability outputs of several base models and then trains a meta-classifier to figure out the absolute best way to combine all their predictions. By marrying the unique strengths of linear models with tree-based ensembles, it achieves this insane level of robustness across virtually all of the tested datasets.
Now, what about the directional forest, the one the AI invented completely on its own? It works by computing a directionality vector to rescale features based on the relationship with class means, and it does this before the decision trees even start splitting. In plain English, it smartly realigns the data up front based on statistical patterns. This gives it incredible stability, especially when you throw really complex, high-dimensional data at it. Okay, section 5, optimizing prompts versus code and the self-improving loop. Once they realized Omega could generate these novel, highly effective algorithms, the researchers asked a fascinating follow-up question. Can it iteratively improve its own winning models? So they set up a self-improving loop with two different pathways. Pathway 1, they asked the AI to write a better natural language prompt to generate a new model. Pathway 2, they asked the AI to directly rewrite and optimize the underlying Python code of the model itself. The results here really surprised me. Across major large language models like Gemini, GPT, and Claude, optimizing the prompt almost universally beat pure code optimization. For example, Claude's performance jumped nearly 9% when it refines the prompt, compared to under 5% when it tweaks the code. It turns out, refining the natural language intent gives you way better performance gains than just fiddling with the raw syntax. What makes all of this truly matter is that this isn't just some abstract theory sitting in a research paper. It has real-world impact, right now. The Omega framework is actually democratizing machine learning discovery by packaging all its best AI-generated models into an open Python library called Omega Models. Because they strictly follow standard scikit-learn formatting, literally anyone can seamlessly drop these newly discovered algorithms into their existing workflows today. So that leaves us with a pretty profound reality to think about. We are watching an AI scientist in its infancy, a system that can hypothesize, code, debug, and validate entirely new algorithms. If AI can fully automate its own foundational research pipeline, what higher-level abstractions, what complex systems are human data scientists going to be freed up to build next? It is a wild time for this space. Thanks for tuning into this explainer, and I hope this sparks some incredible ideas for your own work.